In this lesson we continue to look at writing and following algorithms. Here is our keyword wall. We have two words, implementation and installation, which are part of the software development method. Can you remember what the difference is between these two stages? Well, hopefully you have figured out that implementation is actually building the project, whereas installation is installing it. Look at this algorithm. What programming construct do you think is represented? In this construct, it is selection. We've got two different options with an if and an else. So the program has two choices depending on a criteria. In this case, if age is greater than 18. Have a look at this programming construct. What does it represent? Hopefully you've realised it represents a loop. We've got a for loop here and it's going to repeat code between 1 to 10 times. Have a look at the third programming construct. What do you think it represents? This would actually represent a sequence. Every line of code will be run in order. And finally, look at this programming construct. This is also a loop. It has a repeat. The code inside the repeat will continue to be repeated until it meets the criteria. In this case, it's a do until. So it will always run the code once and then do the criteria at the end of the code. There are three programming constructs: sequence, selection and iteration. A sequence will run your code in order, starting from the top and finishing at the bottom, usually starting with line 1 and executing all subsequent lines afterwards. Selection uses an if statement. You've probably seen it with an if and else, or an if, elif and else. It will only run parts of the code depending on a criteria and will jump over the rest of the lines of code. Usually within a selection statement you will have some form of sequence. There might be a series of sequence of lines that it will follow if that criteria is met. But this is the only construct that actually doesn't all work in a sequence because it moves to different parts of the code. And finally, iteration. This will execute the same lines of code over and over in a loop. There are actually different types of loop that you need to know for the exam. You'll have come across for loops and while loops. However, repeat until loops are slightly different. A repeat until loop will always run the code once and the criteria is at the end of the code. The code will then be repeated if the criteria is still true. You've now got a mini exam question. I want you to try this exam question looking at the code in front of you, and then we'll have a look at some of the answers. Let's have a reminder what an algorithm is. Remember, an algorithm is a set of instructions which are designed to solve a particular task. And a well-designed algorithm will list every instruction that computer actually needs to solve the problem, usually in a sequence, but it might have selection and iteration in there as well. We now need to think about what makes a good algorithm. A good algorithm is made through clear and sequenced steps that produce the correct output for valid inputs. It should allow for only valid inputs, so we need some form of validation there, and it must terminate at some point. It should execute efficiently, thinking about memory and time efficiently, and in as few steps as possible, and it should be designed in a way that other people are able to understand and modify the code if needed. There are two types of algorithms that you might encounter in the exam. These are flowcharts and pseudocode. We use these kind of algorithms so that they are non-program specific. It's important that if you're working together with other programmers that you can all speak in a common language. Let's have a look at flowcharts. First of all, a flowchart always has a start and a stop symbol. These always start or stop a flowchart, and they have rectangles with curved edges. A process symbol is where a process takes place, such as a simple process as add 1 to X or append X to a list. These are square boxes and usually have text inside them. An input and output box is usually in the following parallelogram style. This allows the user to input or output a message. Decision symbols are linked to selection in our programming languages, and we use a diamond. When we've got a choice, we usually have two choices, such as, is x equal to 3, if x equals 3, or y, while y is bigger than 3, we'd use a diamond. This is the symbol for a subroutine, or a subprogram, similar to using a function or a procedure when we're thinking about Python. It's a rectangle with inside a rectangle and has the name of the subroutine you want to call. Note a subroutine still has a start and a stop. However, our main program has a start, whereas our subroutines in the start box have the name of the routine. We can use connector symbols if we don't have enough space. If we're drawing them over several pages, we can send somebody to a different page using the connector symbols. Now, as part of your exam, you're going to have to be able to interpret flow diagrams as well as write them. So using the student workbook, try to figure out what the different routines do. There's a really nice website with the following link on the screen. This website will allow you to make flowchart symbols, and you'll need it for the next task. I want you to produce an algorithm which has a cache point, and you can use it to make a simple cash withdrawal transaction. Use the website to help you.